Science is an ascertain knowledge that is gained through observation and experiments. And these observation experiments are being systematically tested. It has a pattern it has to go through. And when it's critically tested and is proven to be generally accepted, then it becomes a what? Becomes a practicable norm. So they are systematic facts or systematic pattern of trying to gather knowledge. That's what science is. And we have basically three types of sciences: the formal sciences, the empirical sciences, and the applied sciences. Formal sciences comprises of all calculative sciences, that is mathematics, statistics, decision theory, logic, theoretical computer science. And we have the empirical sciences that comprises of both the natural sciences and the social sciences. Under natural sciences, they are of two kinds. We have life sciences and physical sciences. Life sciences, we have what we call pure medicine and biology that has to do with anatomy, physiology, forms and function of all the various cell, tissues, organ and systems in human body. Then we have the physical sciences that comprises of the physics, the chemistry, the geography, the earth science and astronomy. Now, on those social sciences, they are of two kinds. We have economics and other social sciences. In economics, we have the micro, the macro, and the international economics. While under other social sciences, we have anthropology, law, history, education, sociology, psychology, political science. These are all other social sciences. Then under applied science, being the last branch of science, we have the engineering and internal medicines. When I say engineering, I mean the chemical, the electrical, and the mechanical engineering. These are just branches of science, are the charts that represent sciences. Now let's go into chemistry in detail itself. Chemistry is a physical or a natural science that studies matter, its structure, its properties, its composition, and changes that matter undergoes. Now, all of those that I've said wouldn't have come in place without what we call the scientific method. What is the scientific method? Scientific method are processes by which scientists all over the world try to solve problems and have a solution for better life. What are these processes? I abbreviated it to be OHETSA. OHETSA. O for observation, H for hypothesis, E for experiment, T for theory, S for scientific law, and A for application. Now, scientists use all their sense organs, the eye, the nose, the ear, the skin, the tongue, to observe. And when they observe, they brought forward a reasonable explanation to solve a particular problem. Now, when you want to be admitted into school, your data have been collected. The same way, problems are gathered. And in a way, trying to get this problem solved, scientists will go in search of all of the pieces that needed to be coupled together in puzzles to make life better for each and every one of us. After observation has been done, then a good idea is put forward, or a good guess in science, which we call hypothesis. This hypothesis will be tested through a pattern that is called experiment, and an experiment can either be positive or negative. If it's negative, it's not absorbable. If it's positive, then it is absorbable. When it's absorbable, we go to the next phase after experiment, which is a theory. A theory is scientifically accepted within a geographical region or a confinement. Now, when it is accepted within a geographical region, it is not extensively accepted. So it might work in Lagos, and when you get to Abuja, it doesn't work. So it's still a theory. But when you get to London or you get to other parts of the world, it does not work because you're not doing it under the same condition. Maybe it's air resistance, maybe it's air affecting. Now, when it's tested under the same condition and it's proven to be true, and everybody accepts that it's the best thing that can ever happen within this experiment that has been done, it becomes a scientific law. At that stage, nobody dare negates it. It becomes something that everybody has to obey at that point of scientific law. And when it becomes a scientific law, all scientific laws are applicable in our daily lives. I tell you that whenever a teacher teaches you on anything about scientific law, ask him or her, what is the practical application to this in our lifestyle, or how does it affect inanimate things around us? If they are not able to give you guides concerning this, then that person is not the science teacher. So now we move on to the next one, application. That application is you knowing what it does apply. Like for example, if I tell you Charles law obeys everything that has to affect cooking in our environment. When you cook rice, you boil, you ovenate, you warm, that's gas law. That's Charles law rather. Volume temperature relationship and the pressure, it's not in mute. It's not ever used Now, when you decide to blow a balloon, you have a deflected tire, you want to blow it up to continue on your journey for effective motion or movement, then that one is a what? It obeys Boyle's law. We're talking about what? The relationship between what? The volume and the pressure. Volume as contained what will be contained in your tire or your balloon, and pressure as regard where the gas is coming from that will be filled into either of these balloons or your deflected tires. So you see that scientific laws has to be applied. Now, I haven't talked about this. I often get questions about, oh, we've talked about this, we've talked about this. Chemistry has its own branches as much as physics and every other sciences has its own branches. So we have the general view of chemistry, and we have the what? We have the secondary view of chemistry. General view of chemistry, we have to talk about the molecular chemistry, the inorganic chemistry, the organic chemistry, the atomical chemistry, the spontaneity chemistry, and the bonding chemistry. These are general views of chemistry. And the secondary views are what? The quantitative, the qualitative, and the what? And the compound enumerations. Now, qualitative, we're talking about salt analysis, appearance, heat, evolution, action of heat. If you talk about quantitative, we're talking about titration, mass volume relationship, percentage match, purity level. We're talking about water crystallization being absorbed, percentage masses of substances. You're looking at what? You're looking at each concentration of both base, acids, or even salts when they are being used up, and their power of hydrogen, the pH, and the calculation of the hydroxyl ion and the calculation of hydrogen positive ion or the hydrozonium ion. These are all secondary chemistry. Now, of course, the compound enumeration deals with all of the element and its compound, chlorine and its compound, sulfur and its compound, hydrogen and its compound, oxygen and its compound. How are these things being prepared in the laboratory? When they are being prepared in the laboratory, what is the common chemical symbol that you get to identify that this is a what? Is a chlorine, this is an oxygen, this is a hydrogen, this is sulfur, this is phosphorus, and all of that. Then how are these gases being collected? We talk about the upward delivery and the downward displacement. So we talk about what? Upward displacement, downward delivery, downward displacement, depending on the density of the what? Of the gas and the solubility of the gas when used up in the chemical reaction. So all of these are no-brainer. And all of these are necessity that a science student must know, or you wanting to become a better chemistry student. I said it in the clip before now, that it's a no-brainer. You should know at least nothing less than the first 50 elements, if not first 70. And you know it in accordance with its mass number and the atomic number, as it regards its physical and chemical properties. So all of these I've stated before, and I'm still saying this now. So, but for this that was asked, this has to be your words, has to be your response. You have to put in the work. There are no two ways about it. Thank you for having me.